5 algebraic proof. This chapter you may have heard me say or may have heard from other students, but it does seem to be the most difficult chapter. Not that it requires a lot of work because we only do 2 or 3 sections in chapter 2. It's just overall it's a concept that you haven't yet worked with in math, and proofs seem to be tricky. So I'm going to try to do the best I can explaining it over video. A proof itself is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. An important part of writing a proof is giving justifications to show that every step is valid. Okay, so if you're good at arguing with your parents or with your siblings, you're going to be good at a proof. If you're logical, you're good at a proof. If you know your definitions, know your properties, and any of the previous stuff that we've learned, then you're going to be fine with proofs. So let's talk about those properties. These are all properties of equality. Equality means we're using an equal sign in all of these properties. So to start off, we have the addition property of equality. And over here, it gives an example using variables. Now, A could stand for a number or a letter or an expression, and same with B and C. So what it's saying is that if A equals B, then we can add C to the side that A is on and add C to the side that B is on, and it's still an equal equation. For instance, you use this all the time when you solve equations. If the problem was x minus 7 equals 10, what do you do to both sides? Well, you would add 7. So what I'm doing is I'm using the addition property of equality. I'm adding the same number on both sides, just like the added C on both sides, and I'm not changing the equal sign at all. This equation is still going to be balanced. It's still going to be equal. Okay, so that's addition property of equality. Subtraction says the same thing, except instead of adding on both sides, you're subtracting. Multiplication property works the same way, except now you're multiplying C on both sides. And the division property, as you may have already seen, it's also the same. You can divide by the same thing on both sides, and it doesn't change the equal sign. It's not making it an unbalanced equation. Okay, so those 4 are what you use to solve equations. This reflexive property is something that's probably, hopefully, common sense to you, but it's saying that A equals A. So basically, 7 is equal to itself, or x plus 1 is equal to itself. Anytime you see the same thing on both sides of the equal sign, that's called the reflexive property. And the way I remember reflexive property is I think of reflection. So A looks in the mirror and he sees himself. 7 looks over this mirror and he sees himself. 7. Same thing. It's reflecting off of the equal sign, so we call it the reflexive property. The next one is the symmetric property of equality. Symmetric property of equality says that if A equals B, then B equals A. So this one's kind of easy to hopefully, like say I had x plus 1 equals 9. Symmetric property says, well, that just means that 9 equals x plus 1. Okay, you can flip the both sides of the equal sign. Symmetric property means reverse the order here. And the way I remember symmetric is think about, well, we haven't talked about it yet, but line of symmetry, flipping things over the line of symmetry. The other way I remember it is if you change the order of the m's here. So I switch the m's, oh my gosh, it's still equal to the word symmetric. Okay, just like if I flip the x plus 1 and the 9 onto opposite sides here, it's still equal. Okay, so symmetric. Transitive is the next one. Transitive property says that if A equals B and B is equal to C, then that means A is equal to C. Okay, so this one, for example, let's say I have if x plus 3 equals 10, and 10 is equal to 2x. Well, what does that mean about x plus 3 and 2x? It means that they're equal. If they both equal 10, if this equals 10 and this equals 10, that must mean that x plus 3 is the same thing as, I can't write, 2x. Okay, so they're transitive. What they're doing is they're eliminating the middleman. 10 was just getting in the way. It was like x plus 3 had a secret, and they told that secret to number 10. But 10 was like, oh, I gotta tell 2x. Okay, well, wouldn't it have been a lot faster if x plus 3 just went directly to 2x and told them? So 10 is just the middle man here, kind of like B was in the middle. A equaled B and B equaled C. Well, I could have just went directly from A to equal C. The last one is the substitution property of equality. You've used this a lot of times. If A equals B, then B can be substituted for A in any expressions. A lot of times it'll say x equals 9, and then it'll give you an expression like 2x equals x plus 1. Well, what are you doing with that 9? You're plugging it in wherever you see an x. That's the substitution property. Okay, so these three right here, reflexive, symmetric, and transitive, are new. I want to talk a little bit more about them because they can be confusing. Want you to notice how many items are used in the reflexive property. Well, I see an A and, oh, that's an A again, so that's only one item. Okay, A. A symmetric property. I have an A and a B. Oh, B and A. Oh, that's the same thing, so I have 2 items there. And then look at transitive. I have A, B, and then B again. Oh, C is a new one, and then I have A and C. Okay, so that's 3 items. A, B, and C are being used. So that's how some students tell the difference about which property it is. The reflexive property only is talking about one thing. 7 is equal to 7. Only talking about 7. Symmetric is talking about 2 things. X equals 9. Oh, 9 equals X. And transitive is talking about 3 things. X equals 9, and 9 is equal to 2x, then that means x and 2x are the same. They're equal. 3 things, x, 9, and 2x. Okay, the other property that we've used before, or you've already used, is the distributive property. It's saying that if you're multiplying a quantity in parentheses, it's like multiplying them individually, a times b and a times c, and then using the operation that was in the center of the parentheses. Okay, so our very first proof that you've ever done, it's solving an equation in algebra. Okay, so it says solve the equation 4m equals 8, or 4m minus 8 equals negative 12, and write a justification for each step. That justification part is the proof. I know you know how to solve this equation. That's not what I'm going to be looking for. I want to know, can you justify each step? Can you tell me what property we're using? So let's start off by solving. How would you solve this? Okay, well, I want m by itself, so I need to move the numbers over here to the right. And this is a subtracting 8, so I'm going to add 8. Well, what have I just used? What property says that I can add 8 to both sides? And if you don't remember, you go back and look. Which one was adding on both sides? Oh yeah, the very first one, addition property of equality. They added c to both sides. So I've just used the addition property of equality. Okay, the next thing that we're going to do, or need to do, is drop down our 4m. These zero out. Drop down our equal sign. If negative 12 plus 8 is negative 4. What is that called? What did I just do? We like to call it, in proof world, simplify. We simplified that by adding an 8 with a negative 8 and the negative 12 with the 8. So I just made it a simpler problem. So that was a simplify step. Next thing we need to do is divide by 4, since m is being multiplied by 4. And what property says that we can divide on both sides? If you don't remember, you can go back and look. Probably division property, and just make sure it's correct. Yep, division property of equality. And the last thing that we do is, remember, the 4 divided by 4 is a 1, so that would be 1m. Negative 4 divided by positive 4 would be a negative 1. And what is that called that I just did? I did it earlier in my proof. I simplified. Okay, so we've just filled in our first proof, justifying each step. We're making an argument on why can we add 8 to both sides. What still makes this equal? Addition property of equality. Okay, this is a check it out, so I would like you to try it on your own. So please pause the video. I will give you a hint. In every proof, we always start out with the given equation. You can write given equation, or you can just write given, and it's always what they want you to start with. Okay, so I started it off for you. I want you to solve the equation and write a justification for each step. This should be fairly simple. Give it your best shot. There's 2 lines there I want you to fill in. Okay, 1 or 2 things could have happened here on the next step. You could have divided by 1/2 on both sides and called it the division property of equality. Or we know that dividing by 1/2 is the same as multiplying by 2. So I used the multiplication property of equality, where I took this side times 2 and this side times 2. Because a times 2 and a 1/2 would 1 out, they would cancel. So I got t equals negative 14. I need to justify these steps though. Okay, so I times by 2 on both sides. What is that called? When I do it on both sides and I'm multiplying, that's the multiplication property of equality. And canceling the 2 and the 1/2 and the 2 and the negative 7, that's simplifying. So typically after you have a property of equality, you're going to have simplify. Okay, so how'd you get from 2 times negative 7 to 14? Oh, that's just a simplify. Okay, this is an application problem, and it says, what is the temperature in degrees Fahrenheit? So our answer is going to be in Fahrenheit when it is 15 degrees Celsius. So it gives us the equation to convert from Fahrenheit and Celsius. We need to justify each step when we solve the equation. Okay, remember we're trying to figure out Fahrenheit and we know Celsius. So let's list the important information. What do we know? Well, we know that equation, and we know that Celsius is 15 degrees right now. So the important information is the equation to convert from Celsius to Fahrenheit. And the other thing that we know is it's 15 degrees Celsius. Okay, so Celsius is 15. What are we thinking we need to do in order to solve this? Well, what would you normally do if you were given this problem and you didn't have to use a proof? Well, normally, since you see C equals 15 and you see a C over here, what would we do? Well, every proof we start with the given equation. And we know that C is 15, and we're trying to figure out Fahrenheit. So we would plug in. What's plug in called? What property do we call that? That's right, the substitution property of equality. So we put 15 in C's place. All right, now what are we going to do? We want to figure out Fahrenheit, so we want to figure out what F equals. Well, I have 15 times 9/5 plus 32. I'm going to simplify this, so I have a simplify step. 9 divided by 5 times 15 is 27. And then I still need to take 27 plus 32. So what step is this? When I'm just combining terms, I'm simplifying. 27 plus 32 is 59. So F equals 59. That means when it's 15 degrees Celsius, it's 59 degrees Fahrenheit. And this is just checking the answer. So I want you to try a new one. It says, what's the temperature in degrees Celsius? Okay, so this time you're solving for C. And we know that it's 86 degrees Fahrenheit. And here's your equation to convert from Fahrenheit to Celsius. It's 5/9 times Fahrenheit minus 32. So start by listing the important information. Again, I've circled the important information, the equation, and what we know Fahrenheit is. And solve this almost exactly like I did in the previous problem. Okay, so start with the given equation and fill in the rest of the proof. Okay, after the given equation, remember we substitute 86 in for F. So we have a substitution property of equality. We put 86 in its place. Then we're going to follow our order of operations if you want and simplify 86 and 32. Subtract to make 54. So I used a simplify step there. And then again, I need to multiply these two, 54 times 5, and then divided by 9. When I just multiply on one side, notice I'm not multiplying on both sides of the equal sign. It's just one side. That's a simplify step. So I should get a final answer of 30 degrees Celsius when it's 86 degrees Fahrenheit. And again, we can check our answer if you'd like. Okay, so that was part 1 of 2.5, and you're going to have part 2 video coming up next.